Voyager 2's discoveries from interstellar space. The Voyager 2 left our solar system 1 year ago, and recently, a study has been published where the scientific findings of the Voyager 2 have been told. NASA says the Voyager 2 has led to many discoveries, especially on the border that divides our solar system from the interstellar space. Scientists define interstellar space as a place where the sun's continual flow of material and magnetic fields stop affecting its surroundings. There is still much effort to be done by the Voyager 2 regarding interstellar space because this space is told to be about 18 billion kilometers away from Earth. But so far, the findings of the Voyager 2 have been impressive, and we shall be discussing them today. About the Voyager 2. In August 1977, a massive step was taken to elevate space exploration to the next level. NASA spearheaded this movement because they believed that the space exploration should be more critical. It was 8 years after Neil Armstrong took that step on the surface of the moon, so NASA had the vision that they needed to build on this. With the Voyagers being sent into space, NASA believed they did the right thing. Voyagers 1 and 2 were sent into space to help give us a taste of what is out there in space. Our neighboring planets were waiting to be discovered and studied upon. The Voyagers provided a fantastic route to these studies. Mission. Voyager 2 began transmitting images of Jupiter on April 24, 1979, for time-lapse movies of atmospheric circulation. Unlike Voyager 1, Voyager 2 made close passes to the Jovian moons on the way to the system, with scientists especially interested in more information from Europa and Io, which necessitates the 10-hour-long volcano watch. During its encounter, it relayed back spectacular photos of the entire Jovian system, including its moons, Callisto, Ganymede, Europa, at a range of about 127,830 miles or 205,720 kilometers, much closer than Voyager 1. Io and Amalthea, all of which have already been surveyed by Voyager 1. Voyager 2's closest encounter to Jupiter was at 2229 UT July 9, 1979. At a range of about 400,785 miles, 645,000 kilometers. It transmitted new data on the planet's clouds, its newly discovered 4 moons and ring system, as well as 17,000 new pictures. When the earlier pioneers flew by Jupiter, they detected few atmospheric changes from one encounter to the second. Still, Voyager 2 detected many significant changes, including a drift in the Great Red Spot and changes in its shape and color. With combined cameras of the two Voyagers, at least 80% of the surfaces of Ganymede and Callisto were mapped out to a resolution of about 3 miles, that's 5 kilometers. Following a course correction 2 hours after its closest approach to Jupiter, Voyager 2 sped to Saturn. Its trajectory was mainly determined by a decision made in January 1981 to send the spacecraft to Uranus and Neptune later in the decade. Its encounter with the sixth planet began August 22, 1981, 2 years after leaving the Jovian system. Imaging the moon Impetus. Once again, Voyager 2 repeated the photographic mission of its predecessor, although it flew about 14,290 miles, 23,000 kilometers closer to Saturn. The closest encounter to Saturn was at 0121 UT August 26, 1981, at a range of about 63,000 miles, that's 101,000 kilometers. Although Voyager 2 had fulfilled its primary mission goals with the 2 planetary encounters, mission planners directed the veteran spacecraft to Uranus, a journey that would take about 4.5 years. Its encounter with Jupiter was optimized to ensure that future planetary flybys would be possible. The Uranus encounter's geometry was also defined by the possibility of a future encounter with Neptune. Voyager 2 had only 5.5 hours of close study during its flyby. Voyager 2 was the first human-made object to fly past the planet Uranus. Long-range observations of the planet began November 4, 1985, when signals took approximately 2.5 hours to reach Earth. Light conditions were 400 times less than terrestrial conditions. The closest approach to Uranus took place at 1759 UT on January 24, 1986, at a range of about 50,640 miles. That's 81,500 kilometers. During its flyby, Voyager 2 discovered 10 new moons, given such names as Puck, Portia, Juliet, Cressida, Rosalind, Belinda, Desdemona, Cordelia, Ophelia, and Bianca. Obviously, allusions to Shakespeare. 2 new rings in addition to the older 9 rings and magnetic field tilted at 55 degrees off-axis and off-center. Detection. The spacecraft found wind speeds in Uranus' atmosphere at high as 450 miles per hour, that's 724 kilometers per hour, and found evidence of a boiling ocean of water some 497 miles, that's 800 kilometers, below the top cloud surface. Its rings were found to be highly variable in thickness and opacity. Voyager 2 also returned spectacular photos of Miranda, Oberon, Ariel, Umbriel, and Titania, 5 of Uranus's larger moons. In flying by Miranda at a range of only 17,560 miles, that's 28,260 kilometers, the spacecraft came closest to an object so far in its nearly decade-long travels. Images of a moon showed a strange object whose surface was a mishmash of peculiar features that seemed to have no rhyme or reason. Uranus itself appeared generally featureless. The spectacular news of the Uranus encounter was interrupted the same week by the tragic Challenger accident that killed 7 astronauts during their space shuttle launch on January 28, 1986, following the Uranus encounter. The spacecraft performed a single mid-course correction on February 14, 1986, the largest ever made by Voyager 2, to set it on a specific course to Neptune. Voyager 2's encounter with Neptune capped a 4.3 billion mile, 7 billion kilometer journey when on August 25, 1989, at 3:56 UT, it flew about 2,980 miles, that's 4,800 kilometers, over the cloud tops of a giant planet, the closest of its 4 flybys. It was the first human-made object to fly by the planet. Its 10 instruments were still in working order at the time. Once past the Neptune system, Voyager 2 followed a course below the elliptical plane and out of the solar system. Approximately 35 million miles, that's 56 million kilometers past the encounter, Voyager 2's instruments were put in low-power mode to conserve energy. On July 8, 2019, Voyager 2 successfully fired up its trajectory, correction maneuver, thrusters, and will be using them to control the spacecraft's pointing for the foreseeable future. Voyager 2 last used those thrusters during its encounter with Neptune in 1989. Discoveries. As for the discoveries of the Voyager 2, researchers said that this spacecraft's scientific instruments managed to discover differences in the density of plasma, which had a collection of charged particles existing in the solar system. NASA also says that these new research reports confirmed that both Voyagers appear to be present in a transitional area beyond the heliosphere. If you don't know what the heliosphere is, then there's no need to panic. It's a protective bubble that protects our solar system. It is created by solar wind formed from charged particles. The border of the solar system where solar winds end and interstellar space begins is called heliopause. Regarding the heliopause data from Voyager 2, it suggests that the heliopause appears to be a lot thinner than expected. Edward Stone is a physicist with the California Institute of Technology and a project leader for the Voyager program. Stone told reporters the findings represent a very exciting time for us. He also said that Voyager 2 missions gave us essential details about how the Sun interacts with materials that fill most of the space between the stars in the Milky Way galaxy. With so much information to be known courtesy of the Voyager 2, this spacecraft goes beyond our expectations. Researchers also said that Voyager 2 had confirmed existence of a magnetic barrier present at the outer edge of the heliosphere, which was observed by the Voyager 1. Without this new data from Voyager 2, we wouldn't know if what we were seeing with Voyager 1 was characteristic of the entire heliosphere or specific just to the location and time when it crossed, Stone said. Leonard Berlanga is a scientist at NASA's Goddard Space Flight Center and a lead researcher on one of its reports. He told the French news agency AFP, "There were some surprises. Contrary to all expectations and predictions, the magnetic field direction did not change when Voyager 2 crossed the heliopause," he said. The Voyager 2 also collected information on the incoming cosmic rays, which hit Earth from anywhere beyond its atmosphere. The data managed to show us that the rays grew stronger as the Voyager explorers went closer to the heliopause. There will be difficult decisions that are going to be made regarding the Voyager 2, but we can only hope that those decisions work in favor of this spacecraft and for it to last longer than it already has. An object giving us so much information to work with, we can only hope for it to keep providing us with even more astounding information. That's all we had for today's video. If you like this video, then do give us a thumbs up, make sure to subscribe to the channel, and press the bell icon so that you don't miss any of our new videos.